Unit 1 Review, Problem 6. 36 loggerhead sea turtle nests were uncovered, and the number of eggs in each nest, which is called the clutch size, was counted. A stem and leaf plot for this sample is given below. Part A. Find the percentile for the nest with a clutch size of 98 eggs. Well, the question asks us to find the percentile. The percentile measures the percentage of all the data that are less than a specified data value. So to find the answer for part A, we need to calculate the percentage of all the nests that have less than 98 eggs in it. A formula for the percentile is given as K, to represent the percentile, is equal to the percentage less than, which is represented with L, the frequency or number less than the specified data value, divided by N, the total sample size, times 100% to convert it to a percentage. Once we get our result, you need to round the percentile to the nearest whole percent. So K, the percentile, is always represented as a whole percentage, not a decimal or fraction of a percent. So K is always rounded to the nearest whole percent. So to do this formula, we need to know N, the total sample size. Well, in the problem, it's explicitly stated that 36 loggerhead sea turtle nests were uncovered in this sample. So N, the total sample size, is 36. But the problem doesn't necessarily have to give you that total sample size. In this case, we were given the stem and leaf plot. And in the construction of the stem and leaf plot, each data value is used in the construction. So you can count each of the leaves in the stem and leaf plot. That is, each of the digits that are displayed to the right of the vertical line represents a particular data value. So if we were to count each of these digits, you would indeed see that N equals 36 total nests were in this sample. Now to find L, the number less than the specified data value, we have to locate the specified value of the 98 eggs. So in the stem and leaf plot, the nest containing 98 eggs is found here, where 9 is on the stem or to the left, and the 8 is the leaf to the right. Together, that makes the 98 egg nest. Now we have to count the number of nests that had less than 98 eggs. And when you go through and count, you see that the 97 egg nest, the 95, the 93, and the 92 egg nest totals 4. So 4 nests contained less than the 98 eggs. Now we could plug these values into the formula to calculate K, the percentile. K is equal to 4, the number less than, divided by N of 36 times the 100%. This equals 11.11111%. K, the percentile, is always rounded to the nearest whole percent. So since the 10th decimal place, the 1 right after the decimal is a 1, and that is less than 5, we just round this result down to a whole percent as 11%. So there's our answer. 11th percentile is the percentile for the nest with the clutch size of 98 eggs. But be sure to provide all of your work and reasoning of solving the problem in your solution. So the answer is that P sub 11, the 11th percentile, equals the 98 egg nest. That is, the nest with a clutch size of 98 eggs falls at the 11th percentile. All the other work displayed here just shows the work and the calculation and the reasoning done to come up with this answer. Now we could answer part B. Find the 70th percentile for this data. Well, the 70th percentile is a specific data value where 70% of all the data are less than it. So looking at our stem and leaf plot, which contains all the data, we see that the lowest number of eggs in a nest was 92. So any value that is below 92 is 0%. That is, 0% of the nests contained less than the lowest, 92 eggs. The highest number of eggs found in a nest was 126. So any value above 126 has all 100% of the data less than it. So here, the entire range of the number of eggs in the loggerhead sea turtle nest ranged from the 0, none of the nests, all the way up to all of them, 100%. We can then look for the 70th percentile by looking at in the region where about 70% of the nests have less than that specific number of eggs in it. We do not have a formula that calculates the exact percentile directly, but we can use our percentile formula we used previously to solve for L, the number that are less than. And then we could use this L number, how many of the nests have to be less than, in order to find the location of the 70th percentile. So here, solving for L, we get the K percentile divided by 100% times N, the sample size. For the 70th percentile, K is 70%, and for this sample, N is 36. So plugging in the 70% for K and the 36 for N, we get the formula L, that the number we need to have less than is equal to 70% divided by 100% times 36. This equals 25.2. 25.2 is not a whole number. So with just 36 nests, we're not able to get exactly 70% less. But we could do the next best thing. So although we can't find a place where 25.2 nests are less than, we can find a place where 25 nests are less than. So counting through our sorted lists of data in the stem and leaf plot, we can count through 25 nests, or 25 of the data values, by starting at 92 and counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So these are the 25 nests that we need to have less than number of eggs to find the 70th percentile. Actually, the L was 25.2, but since it was not a whole number, we need to go up to the next higher location. In this case, the nest that is just above the 25 is 26. So the number of eggs in the 26 nest has 11 on the left in the stem side and 2 to the right on the leaf side. Together that makes a nest with 112 eggs. So this nest right here that has 112 eggs in it has 25 nests that have less than 112 eggs in it, and that is as close as we can get to our 70th percentile. So now we have our answer to part B. 112 eggs is the 70th percentile. But be sure to show all your work and show your reasoning and method of solving the problem. So here, all this work and all this reasoning is what was done in order to get this answer of 112 eggs. So the 70th percentile for the clutch size of loggerhead sea turtle nests in the sample is 112 eggs. Part C. Find the median for this data and interpret the result. Well, the median is the 50th percentile. That is, it's a specific value where half or 50% of all the data are less than it, and half or 50% of all the data are greater than it. So we could use our same approach that we found the 70th percentile in order to find the median, which is the 50th percentile. The median, or 50th percentile, is the center divider, right where half are less than and half are more than. So it's somewhere in this region, right in the middle. Using our formula of L, the number less than, is equal to the K percentile divided by 100% times N, the sample size. For the median, which is the 50th percentile, we use K equals 50%. And for this sample of loggerhead sea turtle nests, N is 36. So plugging those into the formula, we find that L equals 50% divided by 100% times 36 equals 18. 18 is a whole number, so we are able to get an exact 50th percentile, or to get an exact median. That's because we can find a place where 18 of the 36 nests have fewer eggs, and the other 18 out of 36 nests have more than that number of eggs. That gives us the median, or the 50-50 split. So going to our stem and leaf plot, which already has the data ordered from lowest to highest, and starting at the lowest, so 92 eggs, we can count 18 nests. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So these 18 nests should have less than the number of eggs in the median, and the remaining 18 nests that are not checked here should be greater than the median number of eggs. That number needs to fall right at the center divider, the middle of the 18th and the 19th nest, which is here right between 106 eggs and 108 eggs. In order to find that center divider, you can find the midpoint. You could do this by adding the lower number and the upper number and dividing it in half. Here, if you take 106, add it to 108, divide that in half, you get 107. So 107 eggs is right at the median, because that's where half of the nests had less than 107 eggs, and the other half of the nests had more than 107 eggs. So we've answered the first part of part C. The median is 107 eggs. We also have to make sure we show all our work that led to this answer. Now that we've found the median, we can then interpret the result. The interpretation is where we, in words of the problem, explain what this means. Medians are always interpreted the same way. The medians are the center divider. That's where half or 50% of the data is less than, and half or 50% of the data is greater than. In your interpretation, you could either say that the half or 50% is less, or you could say it is half or 50% or more, or you could say both. All of them would be valid interpretations. But also make sure the interpretation is given in words of the problem. So here, one interpretation for part C could be, thus, half of the loggerhead sea turtle nests in the sample had a clutch size less than 107 eggs. Here in part C, we calculated the median on our own. You also have the option to enter all this data that's displayed in the stem and leaf plot into a list in your calculator, and then use the onevarstat command to calculate the median. If you were to do this, you would get the same answer of 107. Either way you do it, just show your work, and if you did it correctly, you'll get the right result.